example here. Example 4, we have to find the inverse of a cubic function. It says consider the function f of x equals 1/4 x to the third plus 3. Determine whether the inverse of f is a function, then find the inverse. And they say the first thing you should do is graph the function, and you could do some point plotting if you like, and you would find out that the function looks, well, excuse me, it looks something like this. So next to the third thing, it's moved up 3. The quarter makes it not so tall, but that's the general graph. You could point plot it. That's basically the picture it says. And then notice that no, and here we're looking for horizontal line. Intersects the graph more than once. So the inverse of f is itself a function. Now this topic goes back to what was going on in that chart that I kind of talked badly about on the prior page, because if the original function passes the horizontal line test, then the inverse is a function. Then it says to find an equation for f inverse, complete the following steps. You see they get you started. You rewrite f of x, then you put in y instead of f of x, because then we can pull the old switcheroo. So instead of x equals, it's y equals. Excuse me, so sorry. Instead of y equals, it's x equals. Then we need to start solving for y. So we're going to subtract 3 from both sides. And so we end up with x minus 3 equals 1/4 y to the third. And then we'll need to continue solving for y. So we're going to multiply each side by 4. So it's 4x minus 12 equals y to the third. And then it says take the cube root of each side, because we have y to the third and we just want y. So y equals the cube root of 4x minus 12. And because it actually is an inverse, remember the original function passed the horizontal line test, we're going to write it f inverse x equals cube root of 4x minus 12. It's worth taking a moment and going back and looking at the last page and contrasting this answer with the answer we just had, which was how we had a thing where we had to limit the domain in order to make it work, and that's because it was a square root. There was a plus or minus business that entered in. And that does not happen here because it's a cube root, right? Odd roots don't have plus minus businesses. Even roots do. So that's what's going on example 4. So then, if we move on to the checkpoint, we have 2 new functions that we need to find the inverses for. So let's start off with number 2. It says f of x equals 2x to the fourth plus 1. First step, go ahead and write it y equals instead, just so we have something to work with. And then we do the switcheroo, right? So x equals 2y to the fourth plus 1. We're taking the x and the y and we're switching them. To keep moving, we're going to go ahead and subtract 1 from each side. So we get x minus 1 equals 2y to the fourth. Got to divide by 2 to continue solving for y. So there's 1/2 x minus 1/2 equals y to the fourth. And then to continue going on here, we need to do some sort of fourth root business to get y equals fourth root 1/2 x minus 1/2. That minus doesn't look very good. Let me fix that a little bit. There we go. But this is an even root, And so we are plagued by the plus minus situation. That means that it's not actually a function. I mean, it could be the plus one or it could be the minus one, and you don't really know. It's not your fault. When we did example 3 a long time ago, the domain was limited, but in this case, the domain isn't limited, so this is as far as we can get. And this is, and they didn't ask, but I'm going to write it anyway, just to remind you, this is not a function. The original thing given to us was a function, but our inverse is not a function. Again, it's not a moral failing on the maths part, it just isn't a function. Now let's look at number 3 instead. Well, it gives a little contrast with what was going on number 2. Well, first of all, just like before, y equals, and then the old switcheroo. So x equals 1/32 y to the 5th. And then we need to go ahead and solve everything, right? So first thing we're going to do is, we're going to multiply by 32. That's both sides of the equation. So 32x equals y to the 5th. And then to finish, we'll need to go ahead and take the 5th root of both sides. So, we got talking about the 5th root of 32x, and that's equal to y. Now the thing about 32, well, first of all, I wrote it like, frankly, like poo. Let me write it nicer. There we go. But 32 is 2 to the 5th, so if you play that fun factor game, a 2 can come out and there aren't any numbers left over. So it's 2 times the 5th root of x. Now in this case, because it's an odd root, 5th root, odd number, because it's an odd root, there isn't this plus minus business. So we're done, and it actually worked because there's no plus minus to be all wishy-washy. So, I'm going to celebrate, and I'm going to go ahead and write it as an actual inverse function. F inverse of x equals 2 times the 5th root of x. Excuse me, the 5th root of x. And this is a function. And, just again, to give the contrast with what was going on before, use some sort of smiley faces or something. But that's all. This one ended up being actually a function. The one before wasn't a function. To be honest, they didn't ask, but it's worth thinking about. Hey, thank you for your time. We're done with the notes for section 4.